Okay, so the next thing I'm going to be working on is this plate amplifier, which I mentioned before. This is a home subwoofer plate amplifier made by Monitor Audio. So this initially came in, and I checked out the circuit to see if I, stood any chance of maybe doing a repair on it. And I instantly recognized the output section. So let's jump in here and have a quick look. So here we have a very common IRS 2092S drive IC. This is the same drive IC as used in the likes of the Pioneer, GM 9601, etc. And the output MOSFETs here were a pair of 61N20, which again are very similar to the MOSFETs which are used in the JBL GTO 14001 that uses 50N20. So pretty similar kind of output section we've got going on here. Now, because this is obviously designed to drive a higher impedance load, maybe a 4 ohm sub or maybe even an 8 ohm sub, I'm not even too sure, we only have one high side FET and one low side FET, and they're pretty high current, 61 amp parts, so these are good MOSFETs. So yeah, only 2 is needed, and pretty small heatsink here that then goes round onto the main sort of plate at the back here. Quite efficient circuit, it's not going to get too hot. So these MOSFETs were actually shorted, these 61N20s, so I had a few spare of those already, so I changed those, and I also changed the drive chip just for good measure. The difference with working on the home stuff, home amplifiers, is that I can't yet power them up in a slow kind of controlled manner like I can with the car amplifiers. So obviously with the car amp, I've got my current limited power supply here. I can just allow 4 amps to pass. I can watch the amplifier turn on slowly, watch the rail voltages build, and I get a good bit of chance, I get a good bit of time to see if anything is not happy with the circuit before it explodes. With a mains amplifier, you're plugging it straight into the wall socket. Even with a 3 amp fuse, that's going to allow quite a bit higher than 3 amps to pass for a short period of time before it blows. If anything's not happy with the circuit, the second you turn it on, bang, it's gone. So in this case, I actually assumed that the power supply circuit in this would be okay, and I assumed that because sometimes these power supply circuits on these home amplifiers are different to car amplifiers. Obviously, we're not converting DC to AC. In a home amplifier, we're looking to convert AC into 2 rails, which is pretty simple compared to DC to AC back to DC again. So the power supply section in here, I assumed was just going to be using a couple of diodes, rectifiers and stuff like that. So I didn't really bother to check to see if there were any MOSFETs or anything that was shorted. However, when I did go to power this amplifier up after replacing the output FETs, I got a big pop and some smoke, and the fuses all blew, and it tripped all the power in the workshop, and so I was like, oh damn. So I thought I'd take a quick look at the power supply section, and actually the power supply section is very similar again to a car amplifier, and I looked into it, and the reason for that is because this amplifier is designed to work off of not just 220 to 240 volts, but also 120, 110, 120 volts. So basically what this power supply section is doing is it's converting your mains into kind of like a DC rail, and then using that to drive some MOSFETs just like a car amplifier would, however just at a much higher voltage. So the MOSFETs which this amplifier uses in the power supply section are none other than 18N50. So this is a FDP MOSFET. I like to use these ones. I always find that then they seem nice and efficient and run cool, these FDP, FQA type FETs. So this is 16N50, which means that this is going to be 16 amps, 500 volts. So this is a 500 volt power supply FET because we're running mains stuff here. I'm going to go ahead and drop these 2 in. Now, when I looked at the power supply section, obviously when you have dead MOSFETs, you can also have dead drivers. So let me take a quick look at the power supply section here and show you what I found. So on here we have these 2 pads, which are for the power supply MOSFETs, and these 2 over here are the rectifiers, just like in a car amplifier, with this being the transformer. On the back of the PCB we have the drive circuit. So the pulses are likely going to be generated in this circuit here, and then just before where the MOSFETs are here, we have drivers, which are these tiny little transistors here, which I've removed, and we also have a couple of tiny little diodes. Now these were damaged, we had some shorted drive transistors, and one of these diodes was also shorted and the other one was open. So I'm going to replace all of those. These are very, very tiny components, so I'm going to have to use my hot air workstation for that. So yeah, I mentioned that before I turned this on and it went bang. So because I didn't check the power supply section properly, I didn't notice that the power supply FETs were dead. So obviously that made a spark, and that's what tripped the fuse. But because the power supply section was dead, it didn't build any rail voltages, so the output section didn't get affected by the bang, the problem, but it also didn't get tested. So there could still be other issues with the output section that I haven't found yet that may cause it to explode when we turn on. So I don't have hugely high hopes for this, but the parts were relatively cheap, so I thought I'd give it a go for my good friend and see if we can get it running for him. So the first thing, like I said, I'm going to do is replace these drive transistors and diodes from the power supply section just here. Now the diode markings are a little bit different. We have a plus symbol just on the diode marking here, and the little line on the diode needs to go on the opposite side. Okay, looking good. So other things we've got on here, obviously we've got gate resistors, which are these 22 ohm gate resistors. Now I checked out, these were okay. And then here we have the MOSFET location, so I'm going to go ahead and suck the holes for those and put the MOSFETs in. Now I don't hold like massively high hopes for this. I don't seem to have great luck repairing home audio stuff, mains power stuff, just because, like I say, you can't turn it on slowly to get any idea as to whether it's going to work or not. You just have to kind of turn it on and hope for the best, and usually it ends up with a big bang. But so for this one, we've actually got to mount the MOSFETs to the heatsink first, screw them down, and then solder them into the board due to how this is all assembled. So okay, cool, let's solder these MOSFET legs in place, and then we can power it up and see if it explodes. I imagine it will probably explode. I bet there's something that I've missed somewhere, and I can't really check the power supply drive before the drivers on this one due to how the grounding works with the mains ring and stuff like that. I can only really check drive waves on the output section, so this is going to be a bit of pot luck as to that we found all the problems. Last thing to do is to plug in the rail voltage headers here that go from the power supply to the main board, and this one it will supply plus minus 15 volts and turn on signal, etc. All the other little things is the main rail voltage ones. Hate working on main stuff, hate powering up for the first time. It's got to remove the fuse from the plug from last time it blew. I have had an idea that would possibly help me work on mains power stuff and get me to power up slowly. The idea is that I would, instead of plugging it into the actual mains, I would use a power inverter, something that takes 12 volts and turns it up to 240 volts AC, like a decent quality one with good protection built in. And I would run that off of my bench power supply that I can see current draw from. So, and also the inverter that I've actually bought, I have actually bought one already for this, has a power reading in watts on the side, so that's very useful. So what that would allow me to do is to monitor the current draw from any mains equipment that I'm working on and trying to repair. I still don't think that it would save the equipment from blowing up if there is a problem on first initial turn on, because the voltage is so high. There is voltage in the capacitors, and I just think that if there's any problem on any mains equipment, you turn it on, bang, straight away, no chance. But at least it would allow me to monitor the current draw and be a little bit safer than just plugging it straight into the mains ring. 3 amp fuse, very important. Don't want too much current going through here if there is still an issue. I'm going to switch on the plug here. Okay, now I'm going to switch the amplifier on. 3, 2, 1. Oh. Okay, something happened. The green light is not on for power. That's not a good sign. I'm going to power it off. Didn't go bang though. I'm actually just going to quickly check and see if the fuse is blown or not in the plug. Oh no, the 3 amp fuse has died. Let's just see if any FETs have died on here. Okay, so the power supply FET seems to be okay. Power supply FETs are intact, they're not bad. The output FETs don't seem to be dead either. Do I want to put a bigger fuse in? This shouldn't need any more than 3 amps to power up, like, at all. I know what you guys are going to say. You're going to be like, fuck it, throw a bigger fuse in. See what happens, see if we get any sparks. I'm so confused right now though. Maybe what I should do is remove the rail voltage thing here, so that we're just powering up the power supply board, and see if that starts killing fuses just like that. Okay, so this time we've got another 3 amp fuse, and we have disconnected the rails from the output section. So I'm going to see whether the power supply section will come on by itself. Okay, 3, 2, 1. Oh, okay. The green light came on and stayed on this time, hey? No, it didn't. Something went bang. Something went bang. It came on, the green light came on, and I heard a little pop. And now it's not coming on at all again. So, power supply section issue then. Fuse is dead once again. So, power supply section is the problem here. So I've actually been messing around with this inverter. I wanted to see whether I could get this thing powered up on the inverter so that I had a control over the amount of current that was going into it, and just, yeah, generally like lack of huge current from the mains. One last thing that I want to do before I give up is try powering up the power supply board with the rectifiers removed. Hopefully this will do the trick. I don't know, it could also kill the inverter, who knows. I hate main stuff, man. Main stuff. There we go. So the inverter is powered up, and I'm just going to reduce the current down here from 20 amps, which is the maximum, down to like, I don't know, maybe whatever that is, 7 amps here, and I'm just going to get ready to power this on, see what happens. Nope, it draws a shit ton of current. So there's something wrong with the way that there's something wrong with the power supply section in here. It's drawing a crap load of current. Yeah, I don't think that's happy at all. It shouldn't be drawing any current because it's not charging any capacitors, you see. Yeah, no capacitors are being charged on the main board here because the rectifiers are out, so they're not charging the rail caps. So let's see, is that heating up? Because that's attempting to power on. So I'm just going to check my thermal imaging camera and see if it's heating up the FETs at all. Okay, there was something that got a little bit warm here actually. It's hard to see what it is on the thermal imager. There is something that gets hot right at the bottom of the PCB, right at the bottom down here. I can't find anything bad, so this time I'm going to go again, but I'm going to look at the top half of the board this time, and I'm going to shove my thermal imaging camera this way into the board. Okay, ready? Oh, I can see something sparking. I can see something sparking, hey? I wonder if I can get a better picture of that. Maybe I'll take my slow motion camera on my phone and see if I can get a better shot of that. I don't want to spark it too much, obviously, but let's just see whether I can tell where exactly that's coming from. Okay, I saw it. I saw exactly where it came from. I'm going to empty the caps again and let's inspect that further. Yeah, you can clearly see that that is not a happy component. There's a whole load of sooted, kind of burnt area here where it's just been sparking away, perhaps. So I'm just going to try and figure out what exactly this is. It's got some markings on it. It's got 5D, and then it's a bit scratched off. So I just measured the resistance, and it has a resistance of 5,300 ohms. Right, so for the mains plate amplifier, I've got this new NTC current rush suppressor, which is a 5D11. Managed to work out the marking, so I'm just going to throw this on here now. I'm not convinced this is going to work. Bearing in mind, this is supposed to read about 5 ohms on the multimeter, DC, and the one I had in the board currently, which was burnt, was reading 5 kilo ohms, 5,000 ohms, and I was still getting excessive current draw. I think this is supposed to be in series with the main power supply, so if I was still getting excessive current draw with 5,000 ohms in series with my current supply, and that was sparking still, what's going to happen when I put 5 ohms in? I don't know, but this is the last part that I can really find on here that's bad. I don't understand what else could be potentially wrong with this, so Just going to try and hope for the best, install it and see what happens. Right, so the inverter's hooked back up. Here goes nothing. Okay, 3, 2, 1. Well, it didn't spark. It did draw a ton of current again. Let me just check the thermal imaging camera. Okay, something is getting hot. Okay, so just that tiny little bit of current pulse got this suppressor thing, whatever it is, to 40 something degrees, 40 degrees. Just looking through my cheeky thermal imaging camera right here. The thing is that the MOSFETs aren't actually getting hot whatsoever. So if there's a short on this board, it's somewhere before the power gets to the... Well, the FETs clearly aren't doing anything here. Because if the FETs were doing something, then like they would get even the smallest bit of heat on them, and they are stone dead cold. There's nothing whatsoever. The only thing getting hot in here is this inrush current suppressor. For it to get that hot that quickly like this, I'm only letting like a tiny pulse of power into the board here. It's pretty much grounding the power straight away. We've got this little connector here. This is the mains power coming in. So we've got live and neutral. So live is on here. So live comes in here. To get to the voltage suppressor, this thing, it's got to go here. This is the voltage suppressor. So at some point after the voltage suppressor, there is a short. I wonder actually, maybe it's when the relay turns on. When the relay turns on, then the current draws. I'm pretty sure. When the relay turns on, then the current draws. Right? So I've got an idea. Let's turn the relay on manually. Okay, so I'm pretty sure that the relay coil is over here. I'm pretty sure that this here is a relay coil. And then I can then easier follow the pathway of the current easier with my multimeter, just having the relay switched on. So I'm just going to solder these power supply leads to the coil of the relay. Okay, there we go. So I'm just going to turn the current right down on the supply, and hopefully that should engage the relay. So the relay engages at about 6 volts there. Okay, so with the relay engaged here, yeah, because you can see it's not drawing any current with the relay engaged. That's good. I am going to just check which points connect, which points join up. So these two here join up when the relay is engaged, and then we've got what looks like a coil here, and that then goes on to some components over here which I can test. Let's temporarily bridge over that point where the relay will normally engage. Okay, sweet as. Now let's continue then down the path. So when the relay engages, it seems that we have a direct short to ground, or like it could be a shorting inductor, but I would have thought the inductor would heat up. So I'm just going to measure now this connection path. Current then continues over here to yet another inductor, which then goes on to a rectifier. So here on the bottom of the board we have a rectifier. Now, I would perhaps maybe expect to see some kind of short on the rectifier itself due to how it's working, but maybe not. I'm wondering whether maybe this rectifier is bad, you know, hey? There is a short there between these two pins of the rectifier. So let's remove that rectifier. I'm not very confident. I think that's probably how it's meant to be designed, but let's remove it and just test it out of circuit and see what the case is. It was 1 and 3 based on where I was looking at it from, which actually the short on the board itself has disappeared. And looking at this part, I can't imagine that minus and AC should be shorted. That doesn't make any sense. So let's see. Is this rectifier bad? Oh! Oh, it's bad! Ooh! Oh yes, that's the problem. Okay. Now I am pretty confident that that might actually be the last Well, no, fucking, I'm not confident at all. That's definitely the reason that we're getting excessive current draw and that suppressor is heating up. That is the main problem preventing this thing from trying to power up, and it's why the FETs aren't getting warm either, because they're not even starting to switch, because we're not even building rails here. So I can replace this rectifier, this bridge rectifier thing, that's no problem, and that will resolve that issue. It will get power into the caps for the rails and it will get this thing trying to run. However, what I am not confident about whatsoever is the repair of the rest of the circuit, like the power supply drive circuit. I don't know whether it's got a faulty PWM generation circuit still. I just repaired the drivers and the diodes. I don't know if the output section is bad in other places. I just repaired the FETs and the driver chip. It could have other problems elsewhere. So replacing this rectifier might solve the issue in no rail voltage being built, but it might also blow other parts on the board that are still bad. So this is one rabbit hole that I have gotten myself into, but we'll keep pushing because now I know where the faulty component was. I'm not going to go and leave it like that, am I? I'm going to replace it. So okay, let's replace this rectifier. Now I'm not going to have one of these laying around, unfortunately, KBU810. So let's order one of those and come back in a different outfit another day. Today we have the new part. This rectifier has come in, and let's fit it and see what happens. Alright, so that's the rectifier fitted. Now what I am going to do is I'm going to put the other rectifier, it's got multiple rectifiers, so that's a rectifier from the mains, and then there's also rectifiers after the MOSFETs have done their switching business through the transformer. So I'm going to put the other rectifiers back in, so that the power supply MOSFETs actually have, you know, something to work against after the transformer. And but I'm not going to connect the main rails, main rail output back to the output side board just yet. I want to power the power supply board up and see what happens without it actually, you know, driving the output board just yet. So I'll put the other rectifiers back in first, and then power it up and see what it does. Okay, let's turn on the inverter here. Oh, that's promising. Green light. Okay, I've switched it off. That's very promising. Got a green light on the amplifier here. And as you saw there, it drew some current a couple of times. It drew current. You heard the clicks from the relays on my power supply. Drew some current from there to get the caps charged and stuff like that. So that was looking promising. I think that was working. We had a green light. I am going to go ahead and now plug the output section in, I think, and just make sure that that works as well. Whew. Okay, looking good so far. I'm actually just going to do that one more time, and with my multimeter I'm going to just check what voltage we have on the rails here without it plugged in. So 68.5 and minus 68.4. Excellent, that's good. So we do have rail voltage being built, so the power supply board is fully repaired. Excellent stuff. So whew, okay, awesome. I'm feeling good. Feeling good, provided the output section board has a decent repair. I just changed the FETs and the driver. I checked loads of other stuff and nothing else seemed bad, but I'm going to go over it one more time, make sure there's no shorted diodes or anything like that around the output section drive circuit, like bootstrap or feedback diodes or anything like that. And then provided there is none of those, this should be good to go. Ready, 3, 2, 1. Output section, 2.7 amps being drawn. Seems to be okay. It seems to be the same amount of current as was being drawn before. Relay has clicked. Only 1.3 amps being drawn now. I don't know, the relay clicked off just for a minute there, and it went to kind of like red-green. Maybe it just kind of went to sleep or something. So what I'm going to do now is I'm going to probe I'm going to stick my multimeter in the speaker outputs and just make sure there's no like excessive DC offset there that will damage the speaker. Provided there's not, I'm then going to hook up a signal and a speaker and see if it comes to life. Oh, minus 5 volts. That's not ideal. And then it kind of goes into protection mode, and then the DC disappears. You see that there? For God's sake. Urgh. Okay, so what I'm going to try and do now is, I think I'm going to try and hook my oscilloscope up, because I want to be able to see the output drive waves, but it's very difficult. Maybe the amplifier doesn't like being plugged into an inverter. Maybe this inverter has dirty output. Maybe I should try just plugging it straight into the mains. Green light, 8.3 volts of AC on the output. Yeah, it turns off. I'm really confused. I don't quite understand. I am really tempted to hook up a speaker. Right, I'm going to go back to my inverter just for this test with the oscilloscope. Okay, there's a fair bit of noise, as we can see, which is probably just due to the inverter doing its thing. So if we power it up, we have 5 volts worth of DC. That's probably what's causing it to go into protect. So now what I want to do then is I just want to take my scope probe and I want to maybe try and probe the output FETs, see why we've got DC there. The low side drain just kind of bumps up to 5 volts, so the output section isn't actually switching yet for whatever reason. Perhaps the IRS 2092 chip isn't being fed with a VCC. Okay, so I'm going to put up the data sheet for the 2092S. It could be that the old IRS 2092S died and it burned the resistor for its VCC pin. That is possible, so it could be that this chip isn't actually getting any power. So I'm just going to go ahead and remind myself which pin that is. So pin number 12 is VCC. That is the chip's power in order to get all the oscillation and stuff working. VAA pin number 1 is also kind of power, but not really, not the same. Pin 12 is main power. So if we go down here, and I know this camera really sucks, I do apologize, I will invest in some new cameras soon that make this clearer, but pin number 12 is 9, 10, 11, 12, this pin right here. So what we're looking for is we're looking for a resistor, usually about 10 ohms. It kind of acts like a bit like a fuse, so we're usually looking for like a 10 ohm resistor that is going to be connected to this pin. So just going to quickly look around the board here. Here we go. There's a resistor labeled 100, which is 10 and then 0, so that should be 10 ohms. So we've got continuity to pin 12 on that side. On the other side, we've got nothing. Well, hey. That was a good guess, wasn't it? That was an excellent guess. What were the chances of that? So yes, good job I did change out the IC, because that would have been dead, the fact that it blew this 10 ohm fuse. So sweet, fingers crossed then, I might just be able to change out this 10 ohm fuse, 10 ohm sort of fusible resistor, and it might actually come to life. Oh, this is exciting. Every time I find something with this, I'm like, oh, this is going to be the last bit. Okay, so the rectifier was the last bit for the power supply board, but I'm pretty sure now, I'm getting pretty confident that this should be the last piece for the output section, and this should come to life now. Yeah, sorry you can't see this now, guys. This is the only angle that I can get the hot air in and be able to do it. So let's refresh those solder pads. And there we go. That's making a solder connection both sides. And lastly, because I don't want any more of these issues, I'm just going to go around every component I can find that is a semiconductor or a capacitor, and just make sure that we don't have any untoward readings anywhere. Yeah, looking good. I'm pretty confident. I don't think there's anything else around there that is bad in the output section. That's obvious anyway. So last time turning it on. Come on. Seems to be in protection. Oh, there's loads of DC offset. Look at the multimeter. Freaking loads of DC offset there. It went straight to protect. Let's see if the FETs died or not. Nope. No, so the upper FETs didn't die, so... Oh. No, that goes right up to... That swings right to like flipping 60, whatever you saw there. Negative rail. It swings to negative rail. Why would it swing to negative rail? What is wrong with it? Yeah. Just swings straight to negative rail, so there's still a drive circuit fault there somewhere. What? How? Checked pretty much everything. I'm so confused. Maybe do I try taking the output FETs out and doing it like a car amplifier repair, where we look for low side switching before we put the FETs in? Now that I can actually use my scope, I've figured out that it actually does work. One thing that I have just noticed from looking at this again is this 4R7 resistor that's next to the 10 ohm one that we just replaced is looking a bit worse than what it was a minute ago. I just rewatched the video of me soldering this down, and this 4R7 looks not so good. And if we measure across the 4R7, we actually just get 10. I'm going to test this diode out of circuit as well. I have replaced the now that I've replaced the chip once again, just to see what happens. Oh no, it went straight to negative rail. Did you see that? On the multimeter. The DC offset didn't actually come in until a little later than before this time. No, it's straight to DC offset there. I reckon, I wonder whether the chip is being killed because that took that was much quicker to go to DC negative rail that time. So I wonder whether the chip is dying, like every time I try and power it up, something is killing the chip there. Yeah, what I might do is take the FETs out and check it without the FETs in, and then maybe change the chip again, because it did seem like the chip died. There was a bit of a delay on that first time that I changed the chip out. That's the first time I powered it up after the chip change, so maybe I'll do that. Okay, now in my determination to get this to work, I might have done something a little bit crazy that really there's no point. Like, at this point, you know, this amplifier would usually be a write-off, but I need to understand what is wrong with this. I need to know for my own education and just general well-being, and I must know what's wrong with this thing, okay? So, bear with me while I explain what I've done. Here we have a Pioneer GM 960 whatever it is, Pioneer GM 9601, which is a 1200 watt car subwoofer bass amplifier. What I have done is I have hooked up the rails plus minus 15 volts and plus 5 volts and the grounds from the car amplifier into the output section board of the home plate amplifier, okay? Now the reason I've done this is because I needed a properly slow current limited way of powering up this output board without it plugging into the mains, and while everything being floating and being able to scope it properly on my oscilloscope. So this mess spaghetti of wires, we've got the rails coming here and here off the rectifiers going into the board here on the rails. We've got the ground which actually goes over to this this 15 volt regulator. We've got the 15 volt regulator coming off there going into the 15 volts pin on here, and the minus 15 volts, and the plus 5 volts we've got coming off the little surface mount regulator on the board going into here, and the grounds are all hooked up correctly as well. So basically what this lets me do is it lets me power the car audio amplifier up, and I'm using the rails and the auxiliary voltages from the car amplifier to diagnose what's going on with the plate amplifier. So I'm going to power the car amplifier up, and we'll see here we have rail voltage. I'll just probe the rails here. Plus 44 volts on the positive rail, and we have all the plus minus 15 volts, I'm pretty sure. Got plus 13, minus 14 is about right, whatever. Plus 5, and yeah, so basically I can now treat this like a car amplifier with it all powered up like this. I can check what's going on. So I don't have the 2092 chip fitted just yet because I actually took some readings and some measurements of the pins here where they should be from the car amplifier. Now the reason I chose this Pioneer car amplifier is because it shares the exact same output section as this plate amplifier. It's a 2092S drive IC with the output feds. It's the same amplifier output architecture. So what I did is this amplifier works, the Pioneer works, so I removed the 2092 chip and I took some voltage readings of the pins with the chip out of the board, because this plate amplifier keeps killing 2092s. I did confirm that. I took one of the chips off and I put it in the Pioneer and it was dead. So this plate amplifier keeps killing flipping chips. So it's gone through 3 already, which is a pain in the ass. So I needed the chip off to work out what was going on. So I've taken the chip off, and with the chip off of the Pioneer, which works, I have confirmed that we have these voltages present on the pads with the chip out. 1, 5, you can see here. This is basically all of the voltages on the various pads of the chip with it removed on a working amplifier. So what I can do now is go ahead and probe these pads with the chip removed and see if there are any differences. This is one thing after another. I hate mains equipment. I will stress this again. I hate it. Right, what I'm going to do is I'm going to take my last remaining good. No, okay, I lied, I've got 2 left. I've got 2 2092S chips left. Okay, I'm going to take one of these. I'm going to fit it to this board. No FETs in. And I'm going to give it like 3 volts worth of rail voltage, okay? And I want to see whether there is negative rail voltage on the low side gate there. Well, I guess now I can try and power it up and see if we get any kind of waves on the low side gate, but I don't think we will. Because I've been, like I say, messing around with this Pioneer amplifier, and you don't seem to get any kind of PWM on the low side gate with these type of circuits, regardless of whether you feed it with signal or not. So I don't think that we're going to be able to see any drive waves before any FETs go in. Nope. So it's not trying to turn the FET on. It's literally exactly the same. The high side, yep, that's not trying to turn it on either. So all seems well, I think. Okay, next thing to do then, I guess, is to probe each of the pins of the 2092S and compare them to my little document that I made from the Pioneer and see if there's any differences between them that I can, tell would cause a problem. There is something that you're supposed to be able to do where you put a capacitor across FET pads instead of a FET, and you can actually get the thing to try and oscillate. I've never done that before though. I can't remember which pins it is. I think you just put one of those little like 104 ceramic caps. I think maybe you put it across the gate and the source, perhaps. That then tricks the drive circuit into thinking there's a FET there, so it then tries to create some pulses. So I could maybe try that. Clutching at straws here. So the only differences that I have come up with for the plate amplifier board is that pin number 6 is minus 3.5 volts as opposed to minus 5 volts. Pin 8 is 0.8 volt above negative rail as opposed to negative 5 volts above negative rail. So pin 8 is supposed to be 5 volts reference to negative rail, but on this one it's 0.8 volts reference negative rail. Pin number 9 is 4 volt above negative rail, whereas on this one it's pretty much the same. I thought, screw it, you know what, let's just put some FETs in. I've put some 640 ends in, just some spare ones that I had laying around, and I'm going to power this up really slowly in hope that I get to see that there's a problem before the chip dies from whatever is killing it. So let's try that now. Let's probe the low side drain. This is where we should get a square wave, provided this all works fine. I'm only going to let, like, I don't know, flip in 2 amps into this board right now. I want to see what happens on the low side drain. Nothing at all. It's possible that we're not activating this this output circuit purely by default, that we haven't actually got the power supply hooked up. Maybe there's like an activation voltage we're missing or something. I've got a feeling that it's got something to do with pin number 5. So pin number 5 on the Pioneer board is actually kind of going up and down, trying to turn the chip on and off, trying to activate it. So if we take a look at the schematic of this, yeah, so pin number 5 is CSD, which is probably something shut down, C shut down. The protection control, yeah, okay, so we need a little bit of voltage on pin number 5 in order for this to come to life. So I might have to just manually feed some voltage into there. So maybe I can force plus 5 volts to pin 5. So now I have 5 volts going into pin 5, which is going into this resistor here. So let's power it up again, hopefully nothing smokes up, and try again to see whether we get any switching or anything, or any kind of waves on the low side gate. Nothing so far. We do have 5 volts there. Okay, so 5 volts is on CSD. There is no hint of any PWM though still. It's exactly the same as it was a moment ago. Let's try applying some signal and seeing if that changes things now. Nope, still exactly the freaking same. Oh god, what is with this thing? Put the 640 ends in and see if that does anything. Truth point, is this going to do anything at all? Why is it not coming on? We've got 5 volts on CSD. Surely that should like activate it, no? Oh mate, what the hell? I have no idea. Maybe it needs to have 0 volts. Maybe CSD needs to be grounded. CSD is now grounded. Still nothing. Oh man, what the hell? Maybe I should just hook up the original power supply board, but without FETs in, and see what that does without the... Yeah, let's just see what that does on the gate. Alright, let's have another go with the inverter then. So, low side gate, and power on. No, it doesn't give us anything. There's nothing there at all, is there? What do you reckon? Fit some 640 ends? See what happens? I really don't want it to kill another chip, but like I haven't changed anything, so why would it not kill another chip? It killed a chip before. So for one last time, I've put some 640 ends in randomly in the board, and we're going to try and power it up just to see what happens, just in case the first 2 times the chip died was a fluke. Literally, this is the last thing I'm going to do with this amplifier. If this doesn't randomly magically work now, this is done. I have spent far too long on this for it to be worth it. I just really, really want to get it working, but sometimes you just have to write it off. Maybe there's an issue on the board somewhere. Like whatever the issue is, like to pinpoint it, it seems like it's just going to be too long and too difficult to find. I've spent far too long on this already, so let's just see what happens. Maybe we'll get some fireworks. Who knows? No, it didn't actually do anything. So even with FETs in there, what the fuck? Even with FETs in there, it didn't attempt to do anything. Why? Nope, I'm done. I am done. This is not getting repaired. If anyone has any pointers or ideas, feel free to let me know. But as far as I'm concerned, my skill and knowledge level have been completely, totally exhausted with this. I do not know what to do next. I don't know why it was killing chips initially, and I don't know why now it's not attempting to do anything with a new chip in. This should be a relatively simple output section to work on. I usually like these drive IC ones. You can just change the chip and the FETs and it works. In this case, that is not the case. So yeah, not a freaking clue. I apologise if this is an anticlimax, but I wanted to show you that not everything is amazing, not everything goes to plan, and yeah, can't always fix everything. There is a limit to my patience and my skill level. But maybe someone more skillful than me will be able to come along and say, hey, oh, you missed this, check this out, do this, and then it will work. I'm quite glad I got the power supply board up and running. That had a lot of faults. The output section, yeah, like I say, no idea. Thanks for watching, guys. Yeah, I'll be doing some more videos like this where it's just a summary of the repair process rather than a live stream, so stay subscribed for that, and I'll catch you in the next one.